Okay, you guys. So we are going to be working with perfect squares today. All right. You may need to give the video a little bit just to load. I know when I use the big camera here so you can see my journal, it takes a little bit, but we are going to be working with perfect squares. Okay, it's a very easy concept. I don't think it's too difficult. I think y'all will think this is very easy. All right, so what a perfect square is. A perfect square, so I'm writing in my math journal. Anytime you see me writing, you should be writing as well. Right? So hopefully you're writing this down. If you need to pause the video to write this stuff down, feel free to do that. Okay? So we're talking about perfect squares today. Now, a perfect square is a number multiplied by itself. So an example would be like for our times tables, we have times tables that are called doubles, right? So here is an easy example, 2 times 2. What does that equal? We should know that one, right? 2 times 2 equals 4. So the product 4 right here, the answer of 4 is a perfect square. 4 is a perfect square because the two factors that are multiplied together are the same number. Okay, so 2 times 2, and that gives us 4. That is an example of a perfect square. So the number 4 is a perfect square. 2 is multiplied times itself in order to get the perfect square number of 4. Okay, so it's pretty simple. That's what it is. All right, a perfect square is a number that is multiplied by itself, or a factor, right? These things are called factors. This 2 here is a factor. This 2 is a factor. Factors are the numbers that are being multiplied. So let's write that down just so we have it for a future reference. So factors are the numbers that are being multiplied. Okay? Factors are the numbers that are being multiplied. All right? So another example of a perfect square could be 4 times 4. That gives you 16. So 16 is another example of a perfect square. All right? I could go on and on. All of my doubles, or even past my multiplication facts. I could get all the way to 12 times 12, which equals 144. And I could still keep going with a perfect square. I could do 13 times 13, right? Now, of course, I might need to work that out a little bit over to the side because we don't memorize up to 13 times 13, all right? But whatever answer I get for 13 times 13, that will be a perfect square answer because the two factors that are multiplied, these two factors that are multiplied are the same factor. It's the same number that's being multiplied together, okay? So 13 times 13 would give us a perfect square of 169, right? So all of these are examples. 5 times 5, 8 times 8, any number you multiply by itself will give you a perfect square, okay? So today, that's what we're going to be working with, all right? So please write these notes down. If you haven't already started, please write these notes down. Now, I have a question for you before we finish with our notes. Would 10 times 5, which that equals 50, is this a perfect square? Is that a perfect square? 10 times 5. Okay, this is separate. Let me draw a line. 10 times 5 equals 50. Is that a perfect square? You should be saying no, because I tell you right up here what a perfect square is. A perfect square is a number multiplied by itself. Okay, so this number here, 10, is it being multiplied by 10 again? No, it's not. And vice versa. We have a 5 here. Is 5 being multiplied by 5? No, it's two different factors. So this is not a perfect square. No, this is not a perfect square because the factors are not the same number. Okay, they're not the same number. All right, so that's our notes for today. Okay, so we're done with the notes. If you need to pause the video in order to write down, finish copying down the notes, please do so. All right, pause that video. But let's go ahead and continue. All right. Okay, so looking at our slide here, all right, looking at our slide here, we have some examples of some perfect squares, right? So I'm going to take some shapes here because I don't have my little drawing tool because I'm not doing Zoom. But if I look at these examples, I have examples of perfect squares. 1 times 1 equals 1. That's why in this box, I have one box because 1 times 1 just equals 1. Over here, for 3 times 3 equals 9, how many boxes do I have? I have 1. Let me get my shapes here. Or actually, let me do a square. I have 1, 2, 3. Oh my goodness, this is harder. 3, 4, 5, 6, 7, 8, and then 9. Okay, if I can move my little square over there. 9. All right, now I'm not going to do the big square because I think you get it. All right, and they tell you over here, 5 times 5 gives you 25. All right, so if I were to count up all these squares, that would be 25 squares. Now, what happens if they were only to give you the squares? What if the equation wasn't there already? How would I figure out what the equation is? Well, to do that, you would count the squares that are across, so that go across, and then go down. Okay, so you would do one side, all right? So it would be like this. You would count from this square across that way. Make this a little bit thicker. And then you would count from this square and go down. Okay, so you see how I have those two lines there? That's how we would come up with this equation. If I count those squares, I have 1, 2, 3, 4, 5 squares that go across, and 1, 2, 3, 4, 5 squares that go down. So that's how they got the equation. 5 times 5 equals 25. Okay, so let's go ahead and continue here on to the guided practice. So let me go to the next slide. So we're looking at slide 2. Let me zoom in a little bit and see how we do. Oh, that's too much. I don't want it that much. Okay, so we'll leave it like that. Now, looking at this first box here for the guided practice, it says in 1 through 3, write yes if the number is a perfect square. Write no if it is not a perfect square. So you should hopefully be able to still watch my little circle here, right? You can't really miss it, right? It's off to the side. And I'm going to be working this out on the whiteboard, all right? So let's start with number 1. Okay, perfect squares are all about our math facts. So again, if you're not really sure with your math facts and what numbers we multiply to get these numbers, you might struggle a little bit. So if you have a multiplication chart near you or nearby that you can use, I would highly recommend using it. So for number 1 there, right? They give us the number 81. And they want us to write yes if it's a perfect square or no if it's not. Now, I need to think, with this number 81, is that a math fact that I should know? Is there any number, when I multiply it, times itself? So for example, do we think that I could multiply 2 times 2 to get 81? Okay, we should all be saying no, because 2 times 2 is definitely not 81. 2 times 2 is 4. But this is what I need to do, all right? If you need to go through all of your math facts to try and figure out what numbers give you that number, you need to do that, okay? So it's not 2 times 2. What about 3 times 3? 3 times 3 would give us 9, okay? So it's not that. Now, you could sit and work through all of those doubles or through all of those multiplication facts, but hopefully we know what two numbers, when I multiply them together, will give me 81, okay? Well, I know my math facts, and I know that we get 81 if we multiply 9 times 9, okay? 9 times 9 equals 81. So I have a factor times itself. Are these two factors the same number? Yes, they are. So that means they are a perfect square. Because they're the same number, these two factors are the same, that means this number 81 is a perfect square. So I would write yes. Okay? So number 1 for the number 81, it is a perfect square. So let's try number 2. Okay? Again, we're thinking of our math facts. Now, I don't know how many of you would know this one. We should. It's part of our math facts, our times tables, what we should know. 144. Okay? So I can use number 1 to kind of help me. I said that 9 times 9 equals 81. All right? So what would 10 times 10 be? That's a math fact. We should know that one. 10 times 10 is 100. So I'm not quite there yet, but I'm getting closer. So I could keep using that to help me. So let me go to 11 times 11. Okay? 11 times 11. Now, not many students know 11 times 11. Y'all study up until the 10, and then for some reason we forget about the 11s and the 12s. Well, 11 times 11 is 121. Okay, so still, we're not at 144 yet, but we're getting closer. What if we try 12 times 12? Does anyone know that one? I know that one. 12 times 12 equals 144. So, does this number match that one? Yes, it does. Are both factors the same? Yes, they are. So, is the number 144 a perfect square? Yes, it is. Okay, good. So this is a way you can use your math facts, those perfect squares, to try and help you figure out the numbers. Okay, start low. Start with the 2s, go to the 3s, the 4s, and so on. Okay. All right, so let's try number 3. All right, for number 3, they give us the number 50. Now I need to think of my multiplication facts. Okay, what times what will give me 50? Well, I know that 10 times 5 will give me 50. And I could do it the other way. 5 times 10 would give me 50. Okay? But is 50 a perfect square? No, it's not. Because these two factors are not the same. I have a 10 here and a 5 here. I have a 5 here and a 10 here. They are not the same number. They have to be the same number, like 5 times 5 or 10 times 10. So is 50 a perfect square? No. No, it is not. It is not a perfect square. Okay? So good. All right, and that 50 was not a perfect square because the factors were not the same. So let's look at number 4 there. Okay? Number 4 is going to be a little bit trickier. All right? So it says use the grid to draw an area model of a perfect square greater than 100. Then write an equation for that number. Okay, use the grid to draw an area model of a perfect square greater than 100. So we have to have a perfect square greater than 100. I know that 10 times 10 equals 100. So it has to be greater than this. So I cannot do 9 times 9 because that gives me 81. That is not greater than 100. That's less. So I need to do a perfect square that is greater than 100. Well, I know that a perfect square is any number times itself. So I just need to make a perfect square that's greater than 100. Well, I could do 11 times 11. Right? I did that one earlier. Does anyone remember what it equaled? That equaled 121. So on that grid there, if I was able to with my pencil, I would fill in 11 squares across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I would do 11 squares down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay? And then I would just fill everything in from there. All right? And I would color it all in. Okay? But that's how I came up with my equation there. Okay? Good. All right, you guys. So let's go ahead and move on to question 5. Okay, so were any of the numbers in exercises 1 through 3 not a perfect square? If so, justify your reasoning. Well, that one was easy. We said that the number 50 was not a perfect square, or we said no, right? Well, why did we say it wasn't a perfect square? Well, it was because to get 50, we can multiply 10 times 5, right, together. But 10 times 5, these are not the same numbers. They're two different numbers. So we have it in our notes, we have it at the top of this page, that in order to have a perfect square, the two factors have to be the same number. So 50 is not a perfect square because the factors are different. They're not the same number. It's as simple as that. Okay, so let's move on to question 6, right? So Sahil wrote that 7 is a factor of a perfect square. And remember, we wrote in our notes, or you should have written in your notes, that a factor is the numbers that are being multiplied, all right? Multiplied together. So 7. He's saying that 7 is a factor of a perfect square. And they want to know, what is the other factor? What factor are we missing? They're saying 7 is a factor of the perfect square. So what is the other number that we're missing? If this 7 is a factor, what factor are we missing here? Now, they're kind of giving us the answer in a way. Think about it. Okay, I'll let you think for a few seconds or pause the video. But we should know, I've said it multiple times already so far, that a perfect square is a number times itself. Okay, so like 2 times 2, 3 times 3, 4 times 4, and so on and so on. So if this factor is 7, what is the missing factor we should have here in order to get a perfect square? Correct. The missing factor would be 7. If this number is 7, this number needs to be 7. Okay? A perfect square is a number times itself. They have to be the same number. Okay? So what is 7 times 7? That equals 49. Good job. All right, so 49, the number, is a perfect square. All right, good job, you guys. So what you are going to do for today, that is what you are working on, right? You are working on perfect squares. So we did the guided practice together. All right, we took a look at slide 2. So your job now is to work on slide 3, the independent lesson here. All right, and then slide 4. Okay, slide 4, there's only one question, so I don't think y'all will have too much of a problem with this, right? Try your best. I know I'm not here today for you to be able to ask me questions, but try your absolute best, okay? Now remember, if they don't give you the equation at first, so looking at this slide here, this independent work, if we look at question 10, right, they give you a grid, right? And they want you to write the equation or the number that would be shown. So, for example, just to kind of give you one, if I give you a square that looks like this, or an array, we'll call it an array, okay? One more. Right? So say I gave you this square. I didn't give you any equation, but I asked you, what is the perfect square that's being shown here? Well, how would you figure that out? Well, this is what you would do, okay? In order to figure out what the perfect square is, you need to count the squares that go across this way, and then the squares or circles that go down, okay? So let me see if I can find a different color Expo marker that might work here. All right, so I'm going to count the squares or the circles that go across, and then I'm going to count the ones that go down. So let me do across first. So I have 1, 2, 3, 4. So how many went across? 4. Good. Now I'm going to count the ones that go down. I'm going to count this one again. 1, 2, 3, 4. How many went down? 4. So we should know that a perfect square is a number times itself. So I got 4 times 4. What will that equal? 16. Good job, right? So this is what you're going to do for questions 10, 11, and 12, and even 8 and 9. Okay, for question 7, they kind of help you out. They give you an answer there. But for questions 8, 9, 10, 11, and 12, this is what you would need to do. Okay, if you need to rewatch this video,